Hi, everyone. Thank you very much, first of all, to the organizers for putting together this very nice program. As many other, I'm really sorry. I'm sorry not to be there in person. Anyway, so let's start. I want to tell you about, I want to talk to you about a project I've been working on together with two students, David Izquierdo, who is actually now Dr. Izquierdo, and Daniele Spinoso. Let me first actually mention, I wanted to introduce my institute, my research center, the Donosti International Physics Center. This is a research institute located in San Sebastian in the Basque country in Spain, who recently opened a new line in astronomy. We were gonna host actually a meeting on black holes in dwarf galaxies in September this year, but we had to postpone it to next June. And most likely, unfortunately, we'll have to postpone it further to 2022. So, but if you're interested in the topic, please stay tuned. Okay, just a little bit of motivation for our work. This is a collection, by no means complete, of many projects that are ongoing or planned or in phase of construction, preparation. That are going to provide a lot of information about supermassive black holes across an extremely wide range of wavelengths, and not only, also gravitational waves, a wide range in redshift, physical scales, and masses, from the early growing black holes of almost seed masses to the brightest and rarest quasars, to the intermediate mass black holes in the local universe, in dwarf galaxies in the local universe. To interpret all these experiments, all the data that these experiments are going to provide, we need a solid theoretical framework. So this is the context in which our work is coming in. So our goal is to build a flexible and general framework to study in a statistical sense the formation and evolution of supermassive black holes within different environments. So for this, we're using the L galaxies. It's a semi-analytical model. It's a model for galaxy formation. It's a very comprehensive model for the formation and evolution of galaxies. And within this model, we're including various treatments for physics of supermassive black holes, like seeding, different phases of growth, dynamics of binary and multiple objects. And we're trying to do this in a broad range also of redshift, from the seed to quasar to the nearby universe, and also from small masses to the quasar scales. The backbone of this model are dark matter simulation. And for this work, we're trying to combine different simulation, different embodied simulation that can capture in a different way different objects. So we go, for example, from the largest with simulation, largest cosmological volume, but lower resolutions, which are very useful to study the statistic of rare objects, like rare quasars, or black hole in very massive clusters. And on the opposite side, we have simulation, which are smaller in terms of volume, but can have a higher mass resolution. And we are using those to study the formation of the early black holes and the evolution of black holes in dwarf galaxies. The way we are doing it is also using what we are called a grafting. So the results of the smaller simulations are used as initial condition for the larger simulation. So somehow, like in the Russian doll, Matryoshka dolls, the largest doll, the larger doll has also inside information, well, also inside the smaller ones. I don't have really time to go much into details, but let me just give you a couple of examples. This is a map of the Lyman-Werner flux and metal diffusions that we are trying to include to study the environment and the properties of the direct collapse black holes in black holes formed in pristine halos. This is another example of a work that was published this year. by David Izquierdo, where we follow the binary evolution, the evolution of binary systems, the merger, the time it takes for the system to merge, and also the subsequent gravitational recoil and the phase, the wandering phase of the merger remnant. And just to give an example of a result, of an interesting result, we find that including recoil, we find that there is a population of black holes that doesn't grow much, and actually we find an offset in the black hole and bulge relation, and these are black holes primarily hosted in pseudobulges, in galaxies with very disdominated galaxies. This is because these black holes spend quite a lot of time outside the center of the galaxy, so they don't have much opportunity for growing for accreting gas. And again, it's interesting that the studying black hole evolution in different environments, in different kinds of galaxy, gives us information also about how their growth is connected to the properties of the host. And with this, I just conclude. Thank you very much. And if you're interested in more details, just contact us. Bye.